Hi PBL4. I just want to make this quick video about our check for understanding. And the first thing I want to say is that problem number 1 was probably the one we had the most trouble on. Not a ton of trouble, but a little bit of trouble. And I just want to remind you, excuse me, about the quotient rule, which you can find in number 399, and some other problems after that. But try that one again with the quotient rule if it gave you trouble. And then the next thing I want to say is that you guys did a great job on number 3, which was asking you for when, if this is the movement of the particle along the x-axis, when will it move in the negative direction? I think you guys did a really nice job analyzing that and saying, oh, well, yeah, it would when t is less than 2, but that's mathematically. And hang on, looking at the domain of the original function, for that original function to exist, don't we need t to be greater than or equal to 2? So in that case, the object never moves in the negative direction, though it slows down. And you can see that in the graph here. If this is the speed of the object, you can see the speed slowly decreasing. And the last thing I want to do is speak to problem 2, which I want to actually give Charlie all the credit for this. I had not thought of it this way, and he did. So I'm going to kind of go to Charlie's problem and maybe take away his presentation for the week. But he had this lovely way of referencing number 408 and rewriting these problems as f dashed of t divided by f of t equaling a constant. And remembering that if it is exponential function, if f of t is a b to the t, then the derivative f dashed of t is a b to the t times ln of b. So that when you set the derivative over the function, you just get a b to the t times ln of b all over a b to the t, which gives you this nice expression here. Easy enough then to solve for b. Easy enough then to recreate the original function, and then you can mess with it with whatever a value you really want. So if we were to create, 3 different ones, we could just say f of t is equal to a e to the negative 0.12t for any a. And create basically however many we want. So thinking about Charlie's number 412, I'll encourage you to go back and look at problem 2 for the check for understanding, which had a similar way about it. And we have another similar one coming up. All right. Thanks for checking that out, and you guys did a nice job on this first check, so I'm feeling pretty good as to where we are.